Alright, today I'm going to go through the basic operation of an automatic grease system on a 757, and we also have a Hyundai 160 right over here we're going to get to in a second. The biggest part of this is going to be making sure that you keep clean grease inside of the system. This is the only way to properly fill it, is through this grease fitting right here. It has a spin-off top that is more for maintenance and being able to clean it. It is not really the best way to fill it up. The biggest problem that we have with these systems is that people open it up, get contamination inside, which causes actually the check valve within this pump element to fail. So what you want to do is grease it from right here, making sure that you're using clean grease. Associated Terminal uses a red grease very similar to this, and when it goes through the system, you'll see the agitator is turning right now. When it goes through the system, it will actually move the indicator pin that is mounted right here on most of the machines. In some instances, it'll be on this side. On these 757s, it's right here. And as you can see, that indicator pin, it just moved up. It'll slowly index in and out. You're not looking for it to move. There it goes. You're not looking for it to necessarily go up or down, but its movement back and forth shows you that grease is actually flowing through the machine. So this is what you want to watch for. The agitator turning inside of the pump only tells you that the motor on the pump is working. It does not tell you that you're actually pushing grease out. So this is the primary thing that you want to be watching for on these machines. The next thing is, this system will be able to tell you if it's got a point that's not taking grease. And the way it does that is it has a pressure relief valve, which is on that T coming right out of the pump. And that little black piece that's on top of there is a 4,000 PSI pressure relief valve. And what will happen is grease will start to ooze out right there if it's got a restriction in the system. If that is happening, you are not greasing the machine anymore. You need to make sure that you contact a mechanic so that they can deal with the problem, find out where the obstruction is or whatever is going on with it. The next thing that we're going to talk about is going to be broken lines. And this is something that's been a bit of an issue for Associated, so we're going to go into a little bit of detail on this. There's two types of line on this machine. There is hose and there is tubing. I'm going to show you how to splice both of these. This is the tubing. What I've done is the fittings that we use to splice it, and this is just a little push-in splice, actually have barbs on the inside and then an O-ring. What has happened in the past, you notice we already marked this. It'll go down this deep. If you push it in just a little ways past the barbs, I felt a click right there, but that's not actually going over the O-ring, so this fitting will still leak. So you've got to push it down till it actually goes all the way down. That's going to be a tight fit. That's around the O-ring. This fitting will not leak anymore. If you want to release it, you can pull back and it'll slide back out. I will tell you, once you put pressure on this, the barbs inside actually will dig into this, and you can actually see it a little bit right there where it's dug in, and it will not come out of there. So you're better to just cut it off and start again. One other thing with that is that you want to use a razor blade cutter, because if you notice, it's a perfectly clean cut that is on there. If you don't use a razor blade cutter, sometimes it'll crimp it. I'll show you on here with the hose. It's perfectly round. If you try to use this, you do not get a perfectly round cut. It is impossible. So you want to use a razor blade cutter, and you can get a perfectly round cut every time. The other fitting that we use on this is a compression fitting. And what you want to do with that, slide the nut on. Make sure the ferrule goes all the way down to where it sits inside like that. So it's got to be that deep inside. If it's only to the edge, when you compress it, as soon as it gets any pull, it just comes right off. So if it goes all the way over like this, when you compress it down, it actually pinches in that area and it cannot come off. So that's the way to make a proper connection there. There are two different types of fittings that go into the block. The fittings that go into the block have these tapered ferrules, and they fit into the block and they make sure that the block doesn't bypass. Now if you notice, there's two differences here on this. One has like the dime, the collar has like the edge like a dime, and that is for the tubing. And what it is that the tubing or the barbs inside of there are made to really sink down into there and hold on to it. The ones for hose are flat. The reason for that is the fitting that goes into that is a metal piece that has to fit over this little area, and the barbs actually catch onto that edge right there. So they have to be able to be stronger and they're flatter. So that's the difference between these two. Any fitting that goes into a block where the lines come out of have to have this on them. If they only have just a flat 1/8 inch NPT surface that you run into there, then it can actually cause it to go to the point of least resistance between those two. The next thing that I'm going to talk about is the hose. Unfortunately, unlike for the tubing where we have the little splice that you can just put in, the hose has to use this. And it's actually two reusable hose fittings that have to go together. The reason for that is because the hose is made up of 3 layers. It's got a black outer layer of nylon, and then like a nylon rope, and then it's got kind of a rubbery tubing on the inside. And so to hold all of those together, we use a reusable hose fitting. Basically it goes on here and it's threaded on backwards. Bring it all the way down to its tight. And then a 7/16. We'll tighten it up, and that's what makes a solid fit. On here, this is not going anywhere. This is rated for 11,000 psi of pressure against it. Once again, unfortunately, you have to put this and splice it onto the other side. All of the fittings that we use for hose are reusable hose fittings, and so what you can do is, instead of putting splices on it, a lot of times it's better to replace the entire line if the line is not very long. Something else to take in consideration is, Dave, let me have you walk back this way. If you have a brake that's on a corner, you don't want to put a splice in an area where there's going to be any movement or where it's in a bend. So obviously this is not going to go in that area. So if you had to splice in here, you would go back into this area here and put your splice here or up in here, or in this case maybe just replace the entire line, because most of these are not very long. The tubing is pretty much the same way. If you have it all the way on and it's constantly bent like this, you can see how it kind of kicks up. What will happen is it'll push against that O-ring, and eventually that O-ring will flatten out and it can leak. So what I usually tell people is don't make a bend within the first inch of where it goes, and then you're in good shape long term. So going from there, a number of the systems have what we call fault indication lights inside of them. These don't. The 800s do. A lot of the other systems that we do, you may be doing some of them in the past. This is going to be a green light. It's either going to be an LED or this is the old incandescent ones that we used to use. And what that's going to do is it's going to tie into the system and let you know if there is a problem with it. It's going to tell you if it's running low on grease. It'll tell you if there's a point not taking grease, or basically if it's just not pumping grease out. If the pump element is starting to fail on you, then it'll replace that. You give that just a second. The next part is that this grease system is put on here so that you don't have to grease your machine and it's taken care of or greasing on an hourly basis. But bottom line is you have to grease this machine. So if something happens to the machine, you're still responsible for it. Every one of the blocks has a grease fitting on it. When you grease here, you're greasing everything connected to that block. Underneath here, you have another block that's catching the rear of the machine. You'll notice that the primary block, the one that has an indicator pin, does not have a grease fitting on it. It's because no grease endpoints are actually connected to this. This is actually feeding the secondary valve. So this one is going back to the back, this is going to the middle, this is going up to the front. So if you grease each one of the individual blocks, and your grease fitting in the front is actually underneath the cross member, that is up in the front. If you're greasing all of those, you're catching all of the points. If the grease system fails for some reason, it is still your responsibility to grease this machine. I'm going to walk through kind of the same things on the excavator that we talked about on the loader. The indicator pin on this machine is set up to where when you're in the cab, you can see it right outside of the window. It's there all day long. Also, the pressure relief valve is the piece that's sticking up on the top of there. So if you have a point that is not taking grease, grease will start to come out right there. We made it very visible for you so that if there is a problem, you will be able to identify it. It is not a leak or anything like that that needs to be tightened up. It actually is a point that is not taking grease, or a block that's not taking grease, or something along those lines. So that is the primary setup for an excavator as opposed to a loader. And then I'll walk you through real fast the secondary blocks on this machine. On this machine, and Dave, you can stay right there, there is a block on this side. This block actually feeds down to the block that's on the Rotex because we're trying to get just a little bit of grease down onto the Rotex. So that's your two for the boom base and the Rotex. And then we're going to step out to the stick. We tried to put this protective piece over this to save it, but there's a grease fitting up underneath here for the stick. And then there's one line that comes directly out, and there's actually a T inside of here with the grease fitting that goes directly to the bucket point to make sure we're getting plenty of grease on the bucket point. This system is actually set up so that 50% of the grease is going out to the bucket point. The other thing is for the H-link. The H-link block is right here, but notice there's no grease fitting on it. It's actually remoted up to here. And the reason it's up here is so if that area gets completely covered, it's perfectly fine. It's not going to affect the block at all. I don't want you digging it out so that you can get to the grease fitting. So you can actually grease it from right here. And I believe that is all the things that we needed to cover.